Um, no, this video is about forces. We're going to talk about forces today. Now, what exactly is a force? A force is a push or a pull. If you push an object, okay, you are exerting a force, or if you pull an object, you're exerting a force. Now, a force, so it's either a push or a pull. Now, what can a force do? Now, a force can make a body move. If the body is stationary, a force can make it move. For example, when you put your foot on the accelerator of an engine, the engine thrust makes the car move. A force can also stop an object from moving. Like, for example, if the car is already moving, you put your brakes on until the car stops or slows down. You can make the car accelerate or decelerate, to speed up or to slow down. A force can also change the shape and size of an object. Now, we're going to talk about different forces. Before we can do that, let's talk about mass. What is mass? Mass is the quantity of matter in an object. Okay, how much quantity of matter an object contains, the stuff from which it is made, and it's measured in kilograms. Okay, we measure the mass in kilogram, and mass is everywhere the same. Now, it doesn't really matter where you are. If you're in space, if you're on Earth, on the moon, on Jupiter, the quantity of matter in the object will still be the same. So it will have the same mass. No, mass is related to inertia of a body. Okay, what is inertia? No, inertia is the reluctance of an object to move. Now, I'm just going to rub this out, and we will talk about the mass and inertia. No, inertia is the reluctance to move or reluctance to stop if the object is already moving. Now, things don't like to move by themselves. You have to apply a force in order to make an object move. Now, if you try to move it too quickly, the object will resist this motion, okay? And it's the inertia and inertia depends on the mass, okay? The bigger the object, the greater the mass, the greater the inertia. And also, if the body is already moving, the body wants to continue to move because of its inertia. And this is Newton's first law of motion, which is also known as the law of inertia, which says that if the body is at rest, it stays at rest, or if it is moving, it will continue to move in a straight line unless a force acts on it and make it stop. Okay, so this is what inertia is. Okay, it's the Newton's first law of motion. Now, we know that inertia, like when you're going in a car at 30 miles an hour, and if the car suddenly brakes, your body is thrown forward. Okay, and the reason for that is because the inertia of your body make you continue to move. So the objects have inertia. They don't like to move or they don't like to stop. For example, you see this trick that magicians do uh, by pulling the tablecloth from under the cups and saucers. You put cups and saucers on the table and then you pull the cloth quickly. If you pull it quickly, the objects stay on the table, okay? And the cloth is pulled out. And because the objects have inertia, it's the inertia of these objects that make them stay. I'm not going to write too much about inertia. I think this is sufficient to know. Now, the next thing that we're going to talk about is the weight. Now, we said mass. No, in everyday language, we don't distinguish between mass and weight. We say the weight of the apple is 2 kilograms, or we can say the mass of the apple is 2 kilograms. Because in everyday life, we don't distinguish. But in physics, weight is the force of gravity on the mass. And it is measured in, the force is measured in newtons. Okay. And the weight depends on where you are. Now remember, mass stays the same everywhere. Okay, mass doesn't change, but the weight will change depending on the force of gravity. Like if you are here on Earth, on Earth, the force of gravity is 10 newtons on every kilogram weight. So if you have a mass of 1 kilogram, there will be a force of 10 newtons acting on it due to gravity. Okay, so we say that the weight of the object is 10 newton. Okay, so we measure the weight in newtons. So it's 10 kilograms per newton. Now, let's take an example. Mass of an astronaut equals 60 kilogram. He's fairly light in astronaut. If his mass is 60 kilogram, no, his weight is going to be weight on Earth. Okay, how much is his weight on Earth? Now we know that on every kilogram there's a force of 10 Newton acting. Okay, so his weight is going to be 60 times 10, which is 600 Newton. So he weighs 600 Newton here on Earth. Now, how much will he weigh on the moon? Where the gravity on the moon is 1/6. Is 1/6 that on Earth. Okay, so because the weight depends on gravity, he will weigh 1/6 of whatever his weight is on Earth. Okay, so we say his weight on the moon is going to be 1/6 times 600, or 600 divided by 6, which is 100 Newton. Now in kilogram, that's only 10 kilogram. So he weighs 6 times less on the moon because the gravity on the moon is 6 times less. Now, if, for example, if you can jump, say, 1 meter high here on Earth, on the moon, because the gravity is only 1/6, you'll be able to jump 6 times higher. In other words, you'll be able to do a high jump of 6 meters, which is the height of nearly height of 2-story building. Okay, so this is the difference between mass and weight. So we say that the weight is equal to mass times gravity. Okay, m times g, where g is equal to the force of gravity, which here on Earth is about 9.8 or 10 newtons per kilogram. G is equal to 9.8 or approximately 10 newtons per kilogram. So on every kilogram, there's a force of gravity. So for the astronaut, okay, mass is 60. 60 times 10 is 600. Okay, we already used that formula. So this is the formula for the weight. The next thing we're going to talk about is the force of reaction. Okay, what is reaction? Now, when an object is resting on the table here, right, and suppose its weight, the mass of this is 1 kilogram, so the weight will be 1 times 10, which is 10 Newton, right? So the force, the force it exerts, the weight is 10 Newton. Now, what is the table doing? The table must be pushing it back up with a force of 10 Newton. So this will be pushing it back up with a force of 10 Newton upwards. Now, what happens if it wasn't? If it wasn't pushing it back up with the force of 10 Newton, then this book that is resting on the table, it will go through the table. Okay? So when you stand on the ground, okay, you exert your weight onto the ground. And the ground is also pushing back up with the same force as your weight. Because if it wasn't, you will just sink into the ground. Okay, so we say that this is the force of action. Action is the weight of the book on the table. The reaction of the table is pushing it back up with the same force. Or you standing on the ground exert a force of 600 Newton. The ground is pushing back with a force of 600 Newton to hold you up. Okay, so this is the force of reaction, R. And R is always equal to the weight. Now, this is a Newton's third law of motion, which says that to every action, there's an equal and opposite reaction. And this has implication in the motion of a rocket, for example. Now, how does the rocket work? Now, all the rocket does is, when it burns fuel, the gases, they come out with a very large velocity. Okay, so the hot gases, they come out with a big force. The reaction of that force pushes the rocket forward. Okay, it's the reaction of the force that pushes the rocket forward. Okay, so this is the force of the gases. This is the reaction force that drives the rocket forward. Okay, this is so to every action, there's an equal and opposite reaction. Now, the same thing with rowing. Okay, when you are rowing with an oar, you push the water forward and the boat moves backwards. Okay, so there are lots of examples of this in nature. So the next thing we're going to talk about is friction. So we talked about the force of weight and reaction. The next one is friction. Now, if you have, say, a block of concrete, and you're pulling it with a force, okay, you got a rope attached to a block of concrete, and you're trying to drag it along on on a rough floor. Now, the concrete floor is very rough, so it will take a large force in order to pull this. The reason for that is because there is a force of friction between the block and the ground. Okay, so we said that there is a force of friction which opposes the motion. Okay, this is the force of friction, which is opposing the motion. And if your force is greater than the force of friction, you'll be able to move the block. If it wasn't, then the block will not move. Okay, now friction is the force between two surfaces sliding over each other. Now, if you if you look at the table, okay, like the table surface looks very smooth, but actually, if you look under a microscope, it's not smooth at all. It's very jagged, okay, like this. It's got hills and valleys like this. Okay, and you have another body which is also jagged, okay, which is not smooth, and you try to make it slide over this, right? So these jagged edges, they catch onto each other, okay, and that's what causes friction. Okay, so friction is the force. So if you try to move this, okay, apart, that's what causes the force of friction. No, friction always opposes the motion. Okay, it's always in, like for example, if you try to drag this block of concrete to the right, the friction will act to the left. Now, if I try to drag it on this side, the friction will act in the opposite direction. Okay, so the force of friction always opposes the motion. It's always against the motion. Now, is friction a good thing or a bad thing? Well, it can be both. What are the advantages of friction? The advantage of friction is that it helps the body to stop. Okay, now when something is moving, right, if you wanted to stop it, we rely on friction. For example, the car, the friction between the tires and the road in a car, okay, is what stops the car. Okay, now if there was no friction, you will never be able to stop. You'll just continue to move. Like for example, if you were driving on the ice, so even if you put your brakes on, your tires will just slip, okay, and you will not be able to stop. You will just slip and slide. So the advantages, and also walking, when you're walking, you push the ground with your feet, and the friction helps you to be able to walk. Now, if the ground was slippery, your feet will just be moving and you won't be able to go forward. So advantages are walking, stopping, okay. For walking, for stopping, you need friction. Now, friction can also be bad, okay. The disadvantage of this is disadvantages. Now, friction produces a lot of heat and it wastes energy. Now, disadvantages are produces heat, waste energy, okay. Like for example, there are lots of moving parts in a motor car engine, okay, and they're rubbing against each other, and that produces a lot of heat, okay, and that wastes energy, and it causes wear and tear. Now, we must, in that case, we must reduce friction. Also, when something is moving in the air, like aeroplane, for example, moving through the air, there's air friction or the air resistance, which try to slow it down, which produces heat and wastes a lot of energy. Okay, and we must try to reduce it. No, when like these fighter airplanes, okay, when they're moving at Mach 2 or Mach 3 speed, very, very fast, their bodies, they become very, very hot, okay, hot to the touch. So when they land on the ground, and if you touch them, they're very, very hot to the touch because the friction with the air has produced so much heat that has made them hot. If you're sliding down on a rope, okay, that also make your hand burn, okay, because of the friction. The friction produces a lot of heat and it wastes a lot of energy. Now, how can we reduce friction? What we can do is we can lubricate the surface. Number one, lubricate. No, that's the reason why we put oil in the engine. Okay, the engine oil, it lubricates the parts, okay, so that it makes it slip easy. Like for example, if these two are sliding over each other, if you put a layer of oil in between, okay, now this layer of oil will will keep the two surfaces slightly separate apart, and it will make them slip easier. Okay, so that's lubrication. Number two, we can say rolling instead of sliding. Now, if you roll the surfaces, okay, like if you have a block of concrete and you are trying to move you're trying to drag it along the ground, it'll be much easier if you put two rollers underneath, right? Uh, you'll be able to drag it much more easily, okay, than if you're just trying to drag it along the surface. That's the reason why we have wheels on the car, okay, because the wheels roll, they reduce the friction, okay, and makes object move much more easily. So first is lubrication, rolling instead of sliding, and we can also streamlining to reduce air friction. Now remember, the bodies of airplanes, cars are streamlined, so that so there'll be less drag or less force of air resistance. Like for example, the airplane is shaped like this. So as the air is flowing, okay, it flows smoothly like this, okay. So there'll be less friction, okay. The surface is streamlined. If it wasn't streamlined, okay, there'll be a big push of air. Okay, so this is about the forces, force of friction. The next thing we can talk about, there's also electrical force. And magnetic. No, if you have two charged particles, like positive and positive, or so we know that if there are two of the same charges, they try to repel away from each other. Or if they are positive and negative, they attract each other. So there's a force between these two. That's the electrical force. Now, the same with the magnets. Okay, if you have a north pole and a south pole, or a north and a north, they repel away from each other. Okay, if you have a north and a south, they attract. Now, these forces are non-contact forces. Okay, we call these are non-contact forces. The bodies, they don't have to be touching with each other in order to exert this force. No, the other forces were contact forces, okay, because the friction is contact force because it has to be in contact with the ground to produce friction. Now, these are non-contact forces. Electric and magnetic forces are non-contact forces. They can act at a distance. And also, the other force we talk about is upthrust. Okay, now upthrust is a force that when you immerse an object in water, okay, like if this is water, the weight of the object is acting downwards, but the water is pushing it back up with a certain force, okay, which we call the upthrust. Okay, and this is the weight. This is the weight, and that's the upthrust. Now, we find that when you put the object in water, it becomes lighter. Now, normally, say if it weighs 10 Newton, okay. Now, when we lower it in water, its weight decreases to maybe 4 or 5 Newton, okay, because of the upthrust, because of the upthrust of the water that is pushing it back up. I think we have to stop the video, otherwise it gets too long. And we're going to continue on this topic of forces. We're going to talk about the resultant force and other topics, components of force in the next video.